So, solving more equations. So this time we're looking at an equation. So we've got cosine of 2 theta plus sine theta equals 0. And again, we're solving over the interval from 0 to 2 pi. Okay, so notice we have two different functions here. So it would be nice if I could make some kind of substitution to make this all in terms of the same trig function. So one thing that I notice is I know there is a double angle identity for cosine. So let's take a look. So here's the formula sheet. So cosine of 2 theta has 3 different equations we could substitute for it. So one of them only contains the sine function. So I'm going to choose 1 minus 2 sine theta to substitute in for cosine 2 theta, and then I'll have my equation just in terms of sine. So let's make that substitution. So we will have, instead of cosine 2 theta, 1 minus 2 sine squared theta, and then writing the rest of the equation, plus sine theta equals 0. Okay, so looks like I will have something in quadratic form, so I'm just going to rewrite this. I like to have the squared function positive, so I'm actually going to rewrite everything on the other side of the equation. So if I think of this as 0 equals, then that would be a positive 2 sine squared theta. Minus sine theta, and then minus 1. So remember, quadratic form, we would have our squared function, and then the single function, and then the constant. So I want to think about how this would factor. So if it factors like a quadratic, right, we're going to go to 2 parentheses. We're like reversing FOIL. And so in my mind, I'm thinking, okay, this term times this term, because that would be the firsts, right? The f in FOIL would have to multiply to 2 sine squared theta. So my options really are 2 sine theta times sine theta. So if I multiply those two things together, I would get 2 sine squared theta. So these two spots, right, would be the L in FOIL, the last terms. So these two would have to multiply to a -1. So if I put a -1 here and a +1 here, then think about what happens when I multiply this out, right? 2 sine theta times sine theta equals 2 sine squared theta. Check. Outside would be minus 2 sine theta. Inside would be plus 1 sine theta. So when I combine those, I would get negative sine theta, and then 1 times -1 equals -1. So I have factored this correctly. So now setting each factor equal to 0, this would be 2 sine theta plus 1 equals 0, and sine theta minus 1 equals 0. And so now I'm going to solve both both of these equations. So getting sine theta by itself, I'll subtract the 1. So 2 sine theta equals -1. That theta looks a little funny, huh? And then divide both sides by 2. So sine theta is equal to -1/2. And then with this equation, taking the -1 to the other side, I'll have sine theta is equal to 1. Okay, so now let's consider solving them both. I'm going to start on the left. So if I have sine of something equals -1/2, I'm thinking about that 30-60 triangle. And since we're looking at a -1/2, I'm considering where sine is negative, which would be in quadrants 3 and 4. So that's where I want to think about those angles. Of course, my reference angle would be 30 degrees or pi over 6. So pi over 6. So if I think of this as 6 pi over 6, then this angle would be 7 pi over 6. And then over here in quadrant 4, let's think of 2 pi is 12 pi over 6. And so the angle with the reference angle of pi over 6 would be 11 pi over 6. So here on the left, theta, on the interval from 0 to 2 pi, we would have 2, 7 pi over 6, and 11 pi over 6. And then over here, thinking about where sine theta is equal to positive 1. So that's when, again, I think it's easier to think about the unit circle, right, and those specific points on the quadrantal angles, right? So here at 0 or 2 pi, we would think of the point 1, 0. Here we would think of 0, 1. Oops. Sorry about that. My pen is acting a little funny. Let me fix that. And then, of course, we would have, negative 1, 0 on this side and 0, negative 1 down here. So sine is the y coordinate, so we would be looking at that pi over 2 angle. So theta is equal to pi over 2. So we have 3 solutions on the interval from 0 to 2 pi. And they are 7 pi over 6, 11 pi over 6, and pi over 2.